If you traveled 10,000 years into the future, what would planet Earth look like? Would most of its surface be covered in volcanoes? Or would it be frozen in ice? What if you traveled even further, to 1 million years in the future? Would all of the oceans have evaporated? Or would it have become one giant water world? Okay, now what about 1 billion years? Would there be any humans left? Or would they have settled in other parts of the galaxy? This is What If, and here's what would happen if you traveled 1 billion years into the future. Let's face it, the chances of any humans being around to greet you when you arrive 1 billion years into the future are pretty low. Several key existential threats face the human race, and if we want to be around in 1 billion years, we'll need to endure them all. We've seen how much we've struggled to come together just to survive a global pandemic. So how do we have any chance of enduring the threats of climate change, overpopulation, global nuclear war, killer asteroids and comets, natural ice ages, and the sun getting a whole lot hotter? Well, let's take a look into the future and find out. Just under 10,000 years from now, we're going to run into a big problem called the Deca-millennium bug. In the year 10,000 AD, software encoding the AD calendar year won't encode dates with more than 4 decimals. Remember Y2K? Yeah, it's just like that, except hopefully we won't panic as much this time around. On the bright side, in 10,000 years, genetic differences and traits between humans will no longer be regional. Traits like skin and hair color will be evenly distributed around the world. Maybe that will help us all get along, finally. 20,000 years into the future, none of the current languages will be recognizable. Future languages will only contain 1% of the core vocabulary words of their present-day counterparts. 50,000 years from now will mark a new glacial period for the Earth, which will start a new ice age. Niagara Falls will have eroded into Lake Erie completely. And, interestingly, a full day on Earth will also increase by 1 second at this point in time. So much more time for activities. In 250,000 years, the Loihi volcano will rise above the water to form a new island in Hawaii. And in 500,000 years, it's likely that an asteroid with a diameter greater than 1 kilometer will hit Earth, unless we can prevent it. The resulting crater will be no less than 400 kilometers across. It will start fires all over the planet and make the air unbreathable. So there's something to look forward to. And in case that's not enough, in 1 million years, we'll likely have another supervolcano eruption, large enough to spew out 3,200 cubic kilometers of ash. It would produce enough lava to fill 75% of the Grand Canyon. This would be similar to the Toba eruption that almost wiped out humanity 70,000 years ago. Oh, and the nearby star Betelgeuse will have exploded into a supernova by this time, making it visible from Earth even during the daytime. In 2 million AD, humanity will have settlements throughout the solar system. This also means that if populations on different planets have remained separate, humans may have evolved into other species adapted to their specific world. In 10 million years, a huge part of Eastern Africa will break off, forming a new ocean basin. In 50 million years, Africa will collide with Eurasia, closing off the Mediterranean Sea, and a new mountain range will form between the two land masses. This mountain range may include a mountain taller than Mount Everest. Out in space, Mars will collide with its moon, resulting in it developing a ring system like Saturn's. In 60 million years, the Canadian and American Rockies will have eroded entirely. In 80 million years, all Hawaiian Islands will be below the water. In 100 million years, an asteroid similar to the one that killed the dinosaurs 66 million years ago will likely hit Earth, one that is 10 kilometers wide. In 250 million years, all of Earth's continents will be fused together like Pangea, except this time it will be called Pangea Ultima. But don't get too attached to it, because in 400 to 500 million years, Pangea Ultima will separate again. In 500 to 600 million years, a gamma ray burst will likely occur within 6,500 light years from Earth. If it strikes Earth, it could damage the ozone layer and trigger a mass extinction. 600 million years from now, the moon will be so far from Earth that total solar eclipses will no longer be possible. And the sun's increasing luminosity will have raised temperatures on Earth so much that it could halt plate tectonics movement. In 800 million years, carbon dioxide levels will drop dramatically and photosynthesis will no longer be possible. Free oxygen and ozone will disappear from the atmosphere, and complex life on Earth will die. And finally, in 1 billion years, the sun's luminosity will have increased by 10%, and the average temperature on Earth will be 47 degrees Celsius. Our atmosphere will feel like a damp greenhouse, and our oceans will evaporate, leaving just pockets of water at each of the poles. When you arrive here in your time machine, be mentally prepared to take in a planet Earth that looks nothing like the one you remember. The human race will be gone, hopefully living its best life on some other far-off planet. Because of the intense heat, lack of water, and lack of breathable air, Earth will be uninhabitable. So you probably shouldn't stay too long. Instead, you should head out to see the rest of the solar system. Maybe you'll find your fellow humans there. What if humanity grew to be so technologically advanced that we were able to leave our solar system and spread across interstellar space? Would we hop from one exoplanet to another, colonizing everything in our way? How could we make traveling across the universe possible? And what would our space civilization look like? This is What If, and here's what would happen if humanity became an interstellar society. No human has ever been outside of our solar system, and only a few of us have actually left the Earth. Even those who blasted out of here in a rocket didn't go too far. There are billions upon billions of planets out there, but they're so far away it would take us a very long time to reach them. If we jumped into the fastest spacecraft ever built, it would take us over 70,000 years to get to our neighboring star system, Alpha Centauri. Even if we could accelerate a spaceship to 99% the speed of light, over 26,000 years would pass until we arrived at the center of our own galaxy, and another 2 million years until we set foot in the nearest neighbor, the Andromeda Galaxy. How could we go about expanding our civilization into space if we're so terribly slow? To become an intergalactic civilization, we'd need to break the speed limit of the universe. But for all we know, traveling at light speed is physically impossible, never mind outperforming it. The universe is enormous, possibly infinite, and our lifespans are too miserably short to cover those kind of distances, even at near light speeds. But let your curiosity take over and imagine we were a civilization that could approach light speed and travel among stars. We'd start with Alpha Centauri, our neighboring star system. Who knows, maybe the exoplanet orbiting this 3-star system would turn out to be habitable. Then, we'd push ourselves out further to discover the billions of other worlds. Not all of them would be suitable for us to settle in. In astronomy, a habitable world is a planet that is just the right distance from its sun-like star to be able to sustain liquid water. But the reality is, humans require so much more than that. Atmosphere, gravity, temperature, they're all important. It's unlikely that we'd find another planet just like Earth. But we could build self-sustaining Earth-like biomes on our giant spaceships where humans could live for generations. Or we could terraform some rocky exoplanets. First, we'd harvest water from a few ice comets. Then, we'd alter the planet's atmospheres to resemble Earth's. Anything to be able to breathe in fresh air again. Even though space would be so accessible, people wouldn't travel around the universe much once the new colonies were established. Even at the speed of light, it would take generations to make a trip to the other side of the universe. Space is just too vast, remember? In this new world, you'd get to travel among stars only if you were a part of a ship's crew, a colonist, or a space miner. We'd send robots to perform our intergalactic chores. Robots don't eat, sleep, or go to the bathroom. They can withstand high levels of radiation and extreme temperatures, all the things that would kill a human being. But if space travel is something you crave, consider pursuing a career as a postal carrier, because the most reliable way to communicate might be through the mail. Surprised? Well, our satellites rely on radio waves to transmit information. Even though these waves travel just as fast as light, they lose their strength over long distances. It's like being too far away from your Wi-Fi router. If humanity did become an interstellar society, we humans would end up spread out across hundreds of light years of space. At least we'd give Earth a break and allow it to recover from our mistreatment.
What if you found out that you had a long-lost relative? And what if that long-lost relative was from a different planet in our galaxy? And what if this faraway planet was home to billions of humans, just like Earth? But these humans don't look anything like us because they're from the future. Could aliens be future versions of humans? How far ahead of us would they be? How much would they have evolved? Would we be able to understand each other? And what would meeting future humans mean for humanity on Earth? This is What If, and here's what would happen if aliens were future humans. In 1947, a mysterious object crashed in the desert near Roswell, New Mexico. You all know this story, but could it really be aliens? The mysterious object was officially declared to be a U.S. Army Air Force balloon. But then, decades later, U.S. Navy Commander George W. Hoover, who had top-secret clearance, revealed that the mysterious crash involved time-traveling humans. Somehow, these future humans had developed the technology to overcome the technological limitations that prevent us present-day humans from making the same type of trip. Some theories suggest that these future humans travel back in time in order to understand their biological past. Maybe these same time travelers helped our ancestors to make huge leaps in scientific and technological knowledge in a relatively short amount of time. But if any of these theories are true, should we be prepared for another alien-human visit sometime in the near future? And what might we expect from this close encounter of the third kind. If aliens, future humans, were to come and visit us again, they would probably look similar to how they appear in movies. Like us, they'd still walk on 2 feet, but their heads and their eyes would be much larger. This fits with predictions of how present-day humans will continue to evolve. We can expect our heads to be bigger and our upper skull to become more rounded to accommodate a larger brain. And as our civilization advances enough for interplanetary travel, our eyes would get bigger so we can see better in dimmer environments that are further away from the sun. Future humans might also find a way to slow the aging process. So it would be possible to make several trips to places thousands of light years away within one lifetime. If we want to travel somewhere that's 60,000 light years away, and if our technology could do it, then it would be a 60-year flight for anyone on board. But when they got back to Earth, 60,000 years would have passed. We'd like to think that humans of the future would solve this problem so they could visit Earth and come home to tell their family and friends about their trip. But if future humans find a way to live for thousands of years, would that lead to a massive overpopulation on whichever planet they inhabit? Well, chances are, if they make it possible to live that long, they will probably succeed in optimizing their existence before that. Their civilization would undoubtedly be a lot more efficient than ours. The reason being is that they could be centuries, if not millennia, ahead of us in evolutionary terms. Future humans would be a lot smarter, and they'd have better technology to maximize their space and live in densely populated worlds without producing the same high levels of pollution that we do on Earth. In fact, you could bet that future humans wouldn't just have better technology, they'd be technology. Just like some humans today have implants to perceive sound or to detect atmospheric pressure, the humans of the future would likely have dozens of technological implants to make their lives easier. Think about everything your cell phone does for you. Now, imagine you could command it with your thoughts and that it would only be a small chip in your brain. A chip or implant like that might also explain why those who claim to have encountered aliens have said that the aliens spoke to them in their native language. Could future humans simply have automatic language translators implanted in their brains? Or would humans of the future evolve past different languages, instead using one universal language, like Esperanto? If you think this topic has more to it than just a what if, then why don't you join us on the What If Discussed podcast? We go further in depth with the possibilities of aliens actually being humans from the future with Dr. Mike Masters of Montana Tech University, who has written a book postulating that aliens are actually future humans traveling back in time to better understand their past, by better understanding us. Imagine a world where humanity has not only gained the ability to travel and populate space, but has progressed even further than that. Humanity can now control and navigate multiple universes. Welcome to one of the most advanced civilizations ever thought of. A Type 5 civilization. What is a Type 5 civilization? What would it mean for humanity? And how would we get to this point? This is What If, and here's what would happen if humanity became a Type 5 civilization. Okay, so before we get to our epic Type 5 civilization, we first need to start at zero. This is unfortunately where Earth is right now. A Type 0 civilization is one that's reliant on things like fossil fuels and still struggling with issues like climate change. Yeah, we've sent people to the moon and rovers to Mars, but we're
far from interstellar travel, and although we have lots of technological advancements, we're still vulnerable to things like natural disasters and pandemics. So, although Earth is highly advanced in many ways, we still have a long way to go before we reach a Type 1 or 2 or 5 civilization. How do we get there? Well, before we get to that, what are these civilizations anyway, and who came up with them? It's known as the Kardashev scale. Developed by Nikolai Kardashev in 1964, the scale categorizes a civilization according to its technological capabilities and energy consumption. Originally, the scale only involved Type 1, 2, and 3 civilizations, but it's since been expanded to include Type 4 and 5. Now, while civilizations 4 and 5 are mostly speculative and theoretical, civilizations 1 through 3 could happen someday. So, how could humans become a Type 5 civilization? Whoa, not so fast. First, we need to get to a Type 1. There's no way a civilization can jump from a 0 all the way to 5. So, let's get started. Type 1 civilization. A Type 1 civilization would be a massive improvement from where we are now on Earth. As a Type 1, we could harness all the energy available to us on the planet. Imagine being able to harness the power of the oceans and the sun. Things like hurricanes and earthquakes would become minor inconveniences, and all our energy would be renewable. Now, to get to this point, the main thing we'd need to focus on would be energy transition. Shifting from non-renewable to renewable energy sources would be the key priority. And it would need to be done at a global scale. Think entire deserts filled with solar panels, wind turbines covering the clouds, and ocean thermal energy conversion plants. Other scientific advancements would also be essential. Things like quantum computing and advanced AI would be key parts of helping us transition into this new civilization. But it's not just about the technology. We'd also need some sort of global governance to help unify the world to tackle these massive challenges. Experts think that this might happen in the next century or two. But we don't have time to wait that long, so let's fast forward and move on to the next type of civilization. We got 4 more to go. Type 2 civilization. This would be a massive leap on all fronts of energy and technological advancement. Being a Type 2 would mean that we'd be able to build extreme megastructures, like this Dyson sphere. This would allow us to harness the power of the sun. And with that, our energy capability would be virtually limitless. We could innovate our way to incredible technological heights. Instead of being tethered to Earth, we now have the power to travel to new planets and start populating them. Mars, Venus, and other planets in our solar system would become our new homes. And overall, the solar system would become a utopia. With humans having this much power, we'd move beyond things like scarcity, war, and inequality. A unified galactic government would span across our star system. But it would take some hard work. Becoming a Type 2 civilization would require all of humanity's effort and span multiple generations. Type 3 civilization. You think harnessing the power of our Earth and Sun is epic? How about an entire galaxy? Well, that's what you can expect when transitioning to a Type 3 civilization. Things like black holes, billions of stars, and other celestial bodies would all be at humanity's disposal to harness and use. This could allow for wormhole travel. We could instantly travel to distant points in the galaxy. And if that wasn't enough, we'd also have the ability to terraform different planets however we please. I kind of want to ski on Venus. Type 4 civilization.
Okay, now is where things get really crazy. A Type 4 civilization is beginning to reach a point beyond our current understanding of the universe and physics. So, naturally, there would be some weird aspects to this upgraded version of humanity. Being able to terraform planets and control celestial bodies was so last civilization. Now, we reshape, destroy, or create entire worlds. We would have unlimited power, having mastered the resources of the entire universe. Things like artificial intelligence would become so advanced by this point that they'd become part of the structure of the universe. With that, we'd be able to control virtually every aspect of everything. We could manipulate time and create different timelines, create new life forms and different kinds of matter. And on top of all that, in a Type 4 civilization, we'd be able to transcend biological limitations and achieve a form of immortality. Pretty crazy, right? Well, we're not even done yet. Type 5 civilization. Similar to a Type 4 civilization, a Type 5 civilization would be dealing with problems and obstacles that we can't even comprehend. But what we do know is that this civilization would be able to do virtually anything. The people, or whatever they would evolve to at this point, would essentially become gods. They could instantly create new universes with specific conditions that they could use to experiment with new life. They could effectively create their own simulations, ones that are even more complex than the world we live in today. And the key difference would be that a Type 5 civilization would have access to and control of multiple universes. Yeah, instead of being limited to just one puny universe, we would now become a multiversal civilization. This means everything we could do in one universe, our control of energy and our access to resources, would now be multiplied across the entire multiverse. Now, what happens after that is almost incomprehensible. A Type 6 or 7 civilization may mean that humanity merges with the fabric of reality itself. We might go beyond our physical reality. And who knows what happens after that? But no doubt it'd be pretty crazy. 1,000 years into the future, humans might look like this. This is Mindy, a model that shows what we humans might look like in the year 3000. Equipped with a hunched-over back, claws, and a smaller brain, Mindy has adapted this way primarily due to technology and cell phones. But this is just a start of a potential evolutionary journey of the human body. Let's travel 1 million years into the future to see the even crazier ways our bodies will evolve. Super strength, giant eyes, and edited genes are all things you might see later in this episode. But why are we getting all these traits anyway? Well, more on that in a second, but for now, let's check in and see what the next phase of evolution is for humans. 5,000 years into the future. Okay, we're now several thousand years into the future, and in many ways, humans would look relatively similar to how we do now. Yeah, if we look 5,000 years into the past from where we are today, well, humans look basically the same. The main differences are that, well, we're now healthier, taller, and stronger. This is primarily due to how our diet, healthcare, and lifestyle have changed throughout the centuries. This is speculation, but you can assume that a lot will have happened 5,000 years into the future. Changes that include space travel and massive advancements in technology and AI. And how we look all depends on where humans decide to live in the future. If humanity becomes an interstellar civilization, well, we might look like this.
And if we stay on Earth and go all in on AI, well, humans might look more like this. So we'll explore a couple of options as we move through the years. The generations of humans who decide to go to Mars will notice the most significant changes. Mars's lower gravity would lead to less bone density and muscle mass. But the change in gravity might also lead to increased height and longer limbs. And there'll be a lot more changes coming up, but for now, let's take another jump into the future and check on some other options for human evolution. 25,000 years into the future. It's safe to say that technology will play a heavy role in how humans evolve. Traveling 25,000 years into the future, well, you might decide to have a designer baby. Instead of creating life naturally and leaving so many things to chance, you would select various traits for who you want your baby to be. You could choose physical characteristics like hair and eye color, and much more essential features like the ability to avoid certain diseases and allergies. In a way, this is already happening today, but in the future, it'll be more advanced and accessible. It's also likely that humans will begin to fuse with technology, becoming cyborg-like beings. Think neural links, robot limbs, and sensory enhancements. Imagine having a chip in your brain that's equipped with an AI that provides you with any answer you need. Humans will have all these cybernetic enhancements that will make them smarter, stronger, and able to live longer. 100,000 years into the future. One of the ways which we can see how much humans have evolved is by looking at our faces and heads. As you see here, in 100,000 years, our eyes and heads will be significantly larger. This will be due to multiple reasons, one of them being that we'll be living in different environments, like space. Our larger eyes will allow us to see better in low-light environments. They'll also help protect our eyes from the cosmic rays found in space. On Mars, along with bones becoming less dense and limbs continuing to get longer, residents there will need to develop some new survival traits to last this long. As humanity has developed on Mars over the generations, well, they've been experiencing tons of radiation in their environment. That's thanks to the lack of an atmosphere on the red planet. Over time, humanity there has slowly adapted to this new way of life, but the radiation levels are so harsh that they likely haven't adapted enough to live comfortably. One of the problems with evolution is that it's incredibly slow. Seeing significant change in our bodies can take millions of years. So, to fix that, we'll need to make some changes ourselves. You'll see what I mean as we continue on to our 1 million year mark. 250,000 years into the future. Yeah, humanity was tired of waiting and waiting for changes in evolution to happen, so they've decided to do it themselves. We've been altering our bodies with technology for hundreds of thousands of years at this point, but now we're gonna take it to another level. Yeah, instead of adding some sort of enhancement to our bodies, well, we'll now alter our DNA with advanced genetic manipulation. Scientists are already experimenting with this technology, but 250,000 years from now, well, you can bet the science will be advanced beyond belief. Scientists will be able to alter, edit, and even add different genetic mutations, both before people are born and after. In the case of our colony on Mars, well, people on that planet could alter their genes so that the radiation isn't as harmful to their bodies. And that's just the start. Eventually, we'll alter our genes to produce all sorts of insane attributes. You could be brilliant, have super strength, or be immune to every disease. As humanity unlocks this new era of human evolution, things are about to get even better. By the way, are you wondering where we've been getting all these crazy video ideas lately? Well, they come from our Patreon. We've got an exclusive Discord where members get front-of-the-line access to talk about the what-if ideas they want made. Sign up and maybe we'll create your next idea. 500,000 years into the future. Okay, it's been another 250,000 years. Humanity has been playing around with this gene editing thing, and it's gotten pretty ridiculous. Scientists have managed to combine parts of lizard DNA with our human DNA. This has allowed us to regrow our limbs and grow new organs if we need them. Also, along with the help of technology and gene editing, humans are more intelligent than ever. We can now naturally have any appearance we want. This might sound kind of scary, but gene editing like this will likely be essential for us to survive in new environments, like space and our evolving Earth. 1 million years into the future. So, remember the humans back on Earth? The ones who were adding tons of cybernetic enhancements to their bodies? Yeah, they've continued to do that, along with tons of gene editing. And the people in space have been doing the same thing. But as we've been progressing through these 1 million years, well, the environments on Earth and Mars have been very different. And because of these different environments, the humans living on these planets would have different needs and desires for the types of bodies they want. Remember, evolution is all about lifestyle and environment. That's why Mindy, at the start, looked the way she did. It's possible that the humans living on these two planets would be so different that they'd essentially be two completely separate species. Sort of like 50,000 years ago when there were humans on Earth at the same time as Neanderthals. But regardless of how they're different, it's likely that both types of future humans will be the most advanced species ever seen. We'll live longer, maybe forever, be smarter than ever, and be ready to take on whatever challenges the future holds. Speaking of the future, at this point, humanity is likely in a Type 2 or maybe even a Type 3 civilization. But what happens after that? Venus, one of the most fascinating and dangerous planets in our solar system. It's filled with scorching temperatures, crushing atmospheric pressure, and acid rain. But despite these dangers, some people think it might be a better planet for humans to settle on than Mars. But why? And would a human settlement on Venus even be possible? Sit back as we take you on a 10,000-day journey of how humanity could populate this planet. Yeah, maybe. Day 1. Okay, not so fast. Before you set foot on Venus, we're going to have to run some extensive tests and gather more information about this planet. First, we'll need to launch robotic missions and map it out and collect information about the environment. Luckily, we already have a bit of a head start on this. Since 1961, spacecraft have been flying by and profiling Venus. These missions measured things like the topography, atmospheric pressure, and the overall conditions of the planet. But there's still a lot to learn about the Venusian surface.
It's been 30 years since the US has gone to Venus with a mission.
That's Noam Eisenberg. He works for the Venus Exploration Analysis Group, a NASA community whose goal is to keep people updated on new information about Venus. In the 2020s and 2030s, Noam will be part of a satellite mission to Venus to help us understand and see more of the planet than ever before. But today, Noam's going to help us determine whether or not colonizing Venus is a good idea.
You have to wear one or the other of several different science fiction hats in order to make this happen.
Okay, let's put our hypothetical science fiction hats to the test and get started. Day 500. We've been trying to colonize Venus for a little over a year now, and the results have been, well, there's been a bit of trial and error going on with our astronauts. They keep going out to explore the surface of Venus, but keep dying. Why?
So it's not clear that if you were immediately transported there, whether you would burn to death or crush to death first. But certainly both of those things would happen before you asphyxiated in the carbon dioxide atmosphere.
Right. Well, we probably should have listened to Noam a bit closer because it turns out the Venusian surface is incredibly dangerous. 3 reasons why. Venus has one of the hottest surface temperatures of any planet, even Mercury. The surface temperatures reach 467 degrees Celsius. That's hot enough to melt lead, or some unsuspecting astronauts. But let's say we somehow manage to build super heat-resistant astronaut suits. Well, you'd still be met with incredible pressure. The atmospheric pressure on Venus is equivalent to what you'd experience at a depth of 900 meters underwater. This would instantly crush any astronaut. It would also crush and destroy your spaceship as you land. And if you manage to avoid all that, which you won't, but let's say you do, you'll also have to deal with a corrosive atmosphere and acid rain. These conditions are powerful enough to destroy your equipment and eventually melt your skin. Okay, I don't think this is gonna work out. Let's jump ahead and try to terraform Venus to make it more like Earth, day 1000. So, we've been attempting to terraform Venus, and it's been a pretty tricky process. The first problem we'd need to solve would be the atmosphere. To make it similar to what we have on Earth, we'd need to eliminate the carbon dioxide and sulfuric clouds. In theory, we could introduce genetically engineered microorganisms that absorb carbon dioxide. But then there's the scorching temperature on Venus. Now, solving this could be done in multiple ways. One of them involves setting up solar shades in space. This would redirect the sun's rays so they don't hit Venus, which would reduce the solar radiation and cool the planet over time. This all sounds wicked cool from a science fiction perspective, but realistically, we're a couple hundred or thousands of years too early for any of this to be possible. Okay, this is really complicated. Noam, any ideas?
The only way we could inhabit the surface of Venus is if we changed Venus to be much more Earth-like than it is. And right now, we don't have that technology. We don't have that ability. We don't have the resources. If we could terraform Venus, it'd be much, much easier to sort of re-terraform Earth and undo all the damage we've done here. And I don't even know how you would go about doing that. Think about that as science fiction, science fantasy method, right?
Okay, sounds like we should switch our tactics. If humans were to live on Venus, well, it technically couldn't be on the surface. That would just cost too much money, time, and technology that's not available yet. Maybe it's not about living on the surface, but instead living right above it. Let's fast forward. Day 2500. Okay, after years of experimentation, we've finally found the answer about how to live on Venus. I think. The new plan is to create a cloud city 50 kilometers above Venus's surface. Arguably, this could be one of the most comfortable places for humans to exist in our solar system, besides Earth.
That altitude in the Venus atmosphere is kind of actually the most Earth-like any other place in the solar system is. So in that altitude, the temperature is around, depending on where you are, is somewhere between 20 and 30 degrees Celsius, so it could be shirt sleeve weather. The atmospheric pressure is around 1 bar, half to 1 bar.
So up here in the clouds, it would feel like a nice summer day, and the atmospheric pressure wouldn't crush you. Sounds good to me. But what would you live in exactly? Well, we'd create blimps made of Teflon that could be suspended in the clouds. Each blimp could have a different purpose and have different groups of people within it, all connected with covered bridges so you can travel from one end to the other. We'd also be protected from any harmful solar radiation due to Venus's thick atmosphere. That's something Mars can't provide. But despite us making significant progress, these cloud cities wouldn't be without their shortcomings. Day 5000. Okay, we've been expanding and living in these cloud colonies for over 6 years now. We should also mention that you and your space colleagues have been working a ton. Hey, we never said building a new population on an entirely different planet would be easy. If you're going to be one of the people in charge of colonizing Venus, you can expect non-stop workdays. From researching the planet to just setting things up for your daily life and survival. You'd need to build cloud ships that can provide food through hydroponic gardening, and solar-paneled ships that can provide power. This would require an incredible amount of skill and resources. And oops, I forgot to mention another extremely dangerous thing that you need to be aware of. That's the sulfuric acid clouds. They're going to be tricky to avoid, even being 50 kilometers above the surface. Remember, these things are hazardous and could easily melt your skin. Now, not all areas in this cloud city would have these clouds, luckily.
But if you are living in an area where that sulfuric acid is there, then you're talking about a Kevlar envelope, you're talking about things that you need much more protection from, even if temperature pressure is not the major concern.
And the problems might get even worse as we progress to our next phase in populating Venus. Day 10,000. Okay, we've been populating Venus for nearly 30 years now. Hundreds of astronauts have come and gone. Some have even started having children, creating new generations of native Venusians. You've kept busy maintaining and building these cloud ships while learning more about the planet. But over the decades you've been here, life hasn't been nearly as exciting as you thought it might be.
You spend most of your time in this yellow haze, maybe you get to see some sky and stuff like that, so not necessarily the most romantic or inspirational location. So you're living in a box, and most of your view of the surface will be through, automated ports and stuff like that.
And thanks to the acid clouds, it's likely you wouldn't be able to spend much time outside either.
Not the most comfortable environment to live in either the atmosphere or the surface.
Living in these cloud ships doesn't sound all that great. Sure, you'd be creating a new world for humans to live in, but there wouldn't be much exploring. It would just be going from ship to ship, maintaining them, and getting to research a surface that's 50 kilometers below you. Sounds like a tiring and somewhat sad existence. Would it be worth it?
So for permanent habitation in or on or around Venus, I don't think will happen. I don't think it should happen.
But that doesn't mean our hopes for humans becoming an interstellar civilization are misguided.
But I do think that permanent habitation outside of Earth both should and will happen. I believe that, in the long term, multi-century long term, getting all the eggs out of the one basket, getting all the humans off of Earth is what we need to do as a species in order to ensure our, in perpetuity survival.
So maybe populating Venus isn't the best idea. After all, it's impractical, in many ways impossible, and seems like a sad existence for humans anyway.
This is a planetary emergency evacuation. Please remain calm and board your space shuttles.
Even though humanity might not have to leave the Earth in your lifetime, we should start preparing early on. Not only could it take centuries to set up the relocation program, it would take generations to move to a potential new home. That right there is Proxima Centauri B, or just Proxima B. It's the closest potentially habitable planet out there. Its temperatures are in the bearable range, and it could have just the right breathable atmosphere. We only have to get there. How long would our journey last? How many people would we send to populate the new world successfully? And what if it turned out that Proxima B wasn't as habitable as we thought? This is What If, and here's what would happen if we relocated humanity to Proxima B. When astronomers started finding planets outside our solar system, or exoplanets, we realized that there are many worlds out there. That meant that Earth doesn't have to be our home forever, and that we don't have to die with our planet when the sun engulfs it some 5 billion years from now. Now that we've found over 4,100 exoplanets, we've learned something rather disappointing. Not all exoplanets are good for humans to live on. Most of the worlds we've encountered are either ice giants like Neptune or gas giants like Jupiter and Saturn. Only 161 of those planets are terrestrial, like Earth. And when it comes to sustaining human life, being terrestrial isn't quite enough. Proxima B is very promising. It orbits a red dwarf star called Proxima Centauri in a system with 3 stars in it. Proxima Centauri is small. It only has between 7.5% and 50% of our sun's mass. That's a good thing, because the red dwarf Proxima Centauri is so much smaller than our yellow dwarf sun. It burns at a lower temperature. It takes stars like Proxima Centauri much longer to burn through all of their hydrogen supply. Because of that, Proxima Centauri has a lifetime of trillions of years, while our sun has a 10 billion year expiration term. That alone makes Proxima B a good candidate for relocation. That, and the fact that its orbit lies in Proxima Centauri's habitable zone, that means there's the potential for liquid water and comfortable surface temperatures. If we're lucky, Proxima B would have an atmosphere that we could breathe. If it does, the surface temperatures would be in the range of 30 degrees. I don't know about you, but I'd move there right now. I just need to warn you that there are a few problems. A trip to Proxima B would be long and very dangerous. Proxima B might be the closest habitable exoplanet we've got, but that doesn't mean it's close. The red dwarf star Proxima Centauri is about 4.3 light years away. That means that if you could travel at the speed of light, it would take you 4.3 years to get there. Nothing we've built so far can reach that kind of speed. Realistically, a trip to Proxima Centauri in a space shuttle would take 165,000 years, give or take. That's right. Some of the colonists would be born in transit. Some of them would never see the Earth. Some of them would never see Proxima B. They'd just live their lives aboard the spaceship and die in space. How many humans would we need to send on a mission exactly? Well, according to some calculations, 98 people would be just enough. Their descendants would arrive at Proxima B with enough genetic diversity to populate the entire planet. And that's accounting for possible cases of infertility, inbreeding, and sudden deaths. In those calculations, the crew would be traveling on something faster than a space shuttle. Their mission to Proxima B would only take 6,300 years. But don't be surprised. Technology is constantly improving. Right now, a scientific and technological program called Breakthrough Initiatives is looking at how we can get in the neighborhood of Proxima Centauri within 1 generation. Their Project Starshot is working on an ultralight, unmanned probe that would reach the star system in just 20 years. Now I definitely need to sign up. But again, Proxima B is really far away. It's so far that we can't even see if it has an atmosphere. It might just happen that we would arrive at a frozen planet with surface temperatures of minus 40 degrees. And even if it has an atmosphere, it might not be the right one. We might still enjoy warm temperatures, but we'd be doing that in spacesuits with oxygen tanks. Or Proxima B could be tidally locked to Proxima Centauri,
meaning that one of the planet's sides would always face its star, and the other side would be plunged into darkness. Space flight itself could bring some unpleasant surprises. Spending an entire lifetime in a zero-gravity environment would lead the crew members to lose muscle and bone density. They'd be constantly exposed to space radiation. Their microbiomes, immune systems, and physiology would all be different from ours. They wouldn't be the same kind of humans as we are. They would change their values and culture. They might forget all the farming techniques we teach them to sustain themselves in space and on their new planet. They might change their mind about the mission altogether and just turn their spaceship in a different direction. Who knows? They might even come back to Earth and take revenge for all those years they were forced to spend in space. If that happens, I'll be asking for a refund. Sending anyone on a mission like this is a huge risk. We'd need to design and build a vehicle, choose the space travelers very carefully, supply them with all the food and water, and make sure they could become self-sustaining. We'd have to design new propulsion, navigation, hibernation, and life support systems. And we have no way of knowing if Proxima B is actually habitable. Well, now I don't really feel like going there, do you? Imagine an entire network of flying cars zooming around at 2,000 meters above our congested city streets. Your morning commute would be a lot different up there. You could travel at higher speeds, and you could reach almost any remote destination. But what kind of laws would we have to put in place to control the skies? How could we enforce those laws? And how would we deal with the danger of car crashes in the sky? This is What If, and here's what would happen if we had flying cars. The idea of flying cars has been around for almost as long as the car has. And with most people imagining that the future will include some form of flying vehicle, we seem to have accepted that flying cars will eventually become reality. But do we need them? The companies that are currently producing them would say yes, obviously because they'd be much more environmentally friendly than our current gas-guzzling automobiles. But other scientists say that we'd just be replacing one environmental catastrophe with another. Now, before we get too carried away with the environmental impacts of flying cars, let's figure out if it's even possible to fill our skies with them. Several companies have already produced working models, so we know that it's physically possible. But making them a regular part of our society would be much more complicated. For starters, there's the question of who'd be driving them. Would it be us, or some kind of artificial intelligence? According to Aviation Safety magazine, human error is the cause of 90% of non-commercial plane accidents. This is one of the reasons why many experts think that flying cars would need to be autonomous. In other words, humans would not drive them. Studies also show that accidents are much more likely when humans are behind the wheel of the ordinary cars we have now. And remember that up in the air, accidents would be a lot more destructive. Not only would there be high-speed collisions, but there would be the collateral damage of the wrecks falling to the ground or crashing into surrounding buildings. Everyday normal car issues that we experience on the ground would also be a lot more problematic in the air. If your engine breaks down or you happen to run out of gas completely, you can still pull over to the side of the road. You just have to plummet for 2,000 meters before you crash there. Bad weather would also become a much bigger problem on your airborne journeys, as conditions like strong winds could throw your flying car off course and possibly into a tailspin. Maybe there would have to be rules in place for when a flying vehicle could and could not be used because of Mother Nature. And we'd need police up there to enforce those rules, along with other laws regarding speed and allowed elevation heights. But how would a cop pull someone over in midair?
Okay, so clearly there would be a lot of work to do to integrate flying cars into our society, but it'd all be for the good of the environment, right? It is estimated that an electric flying vehicle could be 35% more energy efficient over a 100-kilometer trip when compared to a gas-powered car. But as impressive as this is, it doesn't top what an electric vehicle is currently capable of achieving. On top of that, although we'd be eliminating the problematic gasolines needed for conventional cars, mining the natural elements required for our flying cars' rechargeable batteries would be just about as bad. So maybe flying cars will never be convenient enough for the average commuter to rely on, but that doesn't mean we should stop exploring the technology. Maybe the ideas behind flying cars could lead to bigger and better advancements down the road. Imagine if we could collect energy out of thin air. And I mean it quite literally. You know how you were taught that a vacuum is nothing but empty space? Well, that isn't exactly true, at least in the world of quantum mechanics. If you dive deeper, below the level of molecules, atoms, electrons, and protons, and into the world of the tiniest subatomic particles like quarks, you'll see that even the vacuum of space can never be truly empty. It's filled with particles that randomly pop in and out of existence. But the exciting thing about these fluctuating particles is that they generate energy that we could hypothetically put to good use. How could we harness this vacuum energy? How would taming a source of unlimited power change us? And why could this be dangerous for the planet? This is What If, and here's what would happen if we harnessed zero-point energy. Don't be spooked by its complex name. Zero-point energy is simply the vacuum energy we just talked about. And according to calculations in quantum field theory, the vacuum of space holds an infinite amount of it. If we could find a way to use it, just a cupful of this energy might hold enough power to boil all the Earth's oceans. So, where would we start? In quantum mechanics, things behave differently from how they would in classical physics. For example, you can't know where a particle is until you observe it. What's more, the more accurately you determine the position of the particle, the less accurately you can determine its momentum. It's called the Heisenberg uncertainty principle, and it applies to particle duration and energy as well. Are you still with me? Good, because we're just getting to the cool part. What this uncertainty principle tells us is that zero-point energy exists. We just need to find a way to collect it. How would we do that? The vacuum of space is really cold, right? But it's not the absolute zero kind of cold, more like 2.7 Kelvin. To transfer zero-point energy, you'd simply need a colder source to receive that energy. The problem is, it's not possible as far as our technology goes. We can't pull the energy out of nowhere unless we could reduce the vacuum energy in a region of space first. According to the second law of thermodynamics, the vacuum would try to fill in the gap. And that's where we could interfere and collect the zero-point energy. But this method wouldn't be that effective because we'd spend more energy trying to extract the zero-point energy. I know, it seems like a dead end, but let's do what we usually do in a case when the existing technology hasn't caught up yet. Let's fast forward into the future, where all the extraction issues are resolved and where everything is powered by zero-point energy. Now what? Unlimited energy would mean free or almost free energy. We'd have free public transportation and we would all drive electric cars. Everyone, including developing countries, would have access to cutting-edge technology and to the internet. Non-renewable energy sources would be a thing of the past. Even the renewable sources we use today would be obsolete. Why would we need solar energy farms if we could automate the extraction of unlimited zero-point energy and never need to worry about power again? But as with all things we have in excess, we could start overusing the energy too. The planet might be free of emissions from fossil fuels, but it doesn't mean that there would be no new threats from energy consumption. We'd need our governments to regulate how we use all that energy. Maybe it would be a good idea to focus on exploring space. Powered by the infinite amounts of zero-point energy, we'd be able to go across the solar system in a matter of hours. We could start mining asteroids and terraforming other planets. Imagine traveling at the speed of an airplane, but on ground level, and in a giant tube. That's the idea behind the hyperloop, a network of incredibly fast-moving pods that can carry passengers to destinations all over the world, reducing travel times from hours to minutes. But how would that work? Would it be safe? And what would it be like to ride in one of these pods? This is What If, and here's what would happen if Earth had a global hyperloop network. A hyperloop consists of pods that travel through pressurized tubes using electromagnetic propulsion. This may sound like the stuff of science fiction, but several companies are surprisingly close to making it a safe, viable reality. Once completed, this giant transportation system would connect all major cities around the globe. How would it change the way we live our lives? If all goes according to plan, a hyperloop system would be cheaper, faster, and more environmentally friendly than planes, trains, and automobiles. The first ones would be built on a relatively small scale, covering shorter journeys like Los Angeles to San Francisco. Traveling at over 1,200 kilometers per hour, these speedy pods would take the pressure off gridlocked roads, making travel between cities much easier for everyone. Populations would have the ability to spread out further from city centers, since faster travel times would mean people aren't forced to live where their jobs are located. We'd also have a lot more time to be productive, because we wouldn't waste as much of our days getting to where we needed to go. But the real exciting prospects of the Hyperloop come into play when you look at it on a global scale. First off, international travel would become a whole lot more accessible. Elon Musk, one of the founders of the project, says that tickets would be kept affordable in order to open the service up to everyone. On top of that, international deliveries would be completely revolutionized. With the Hyperloop, we could autonomously ship packages across the world at the cost of trucking and the speed of flight. But before we get too far ahead of ourselves with all the possibilities, what would it be like to ride the thing? Well, for one thing, the pods would be pretty small. They'd have to be narrow to travel at such high speeds, so things might get a little cramped. And you wouldn't have any windows. Instead, there would be augmented reality screens that can simulate scenery or provide entertainment. But the seats would be comfortable, and that's a big deal considering how intense the ride gets. The designers behind the Hyperloop say that riders would only experience unease during the acceleration and deceleration of the trip, a span of only about 2 minutes. But what about when it turns? Have you ever made a sharp turn in your car at 50 kilometers an hour? Well, imagine what that would be like at 1,200 kilometers per hour. One way to smooth it out would be to make huge curves in the track to make long, gradual turns. But that would make for a much larger impact on the areas the tunnels run through. And what if it needed to make an emergency stop? A sudden halt at these speeds would be 10 times worse than a car crash at 110 kilometers per hour. These concerning questions, coupled with the obvious issues that would come with building giant tunnels that span across oceans and numerous governments, are signs that the Hyperloop might just be a fantasy for now.
With 8 billion people on the planet, things can feel pretty crowded. Let's make things a bit tighter by housing every single person on Earth in one giant skyscraper. But a building big enough for 8 billion of us doesn't exist yet. We're going to have to build one from the ground up. But before we do, let's start small and work our way up with one that could hold at least a country or two. We'll start with some of the least populated countries and move on to the most gigantic skyscraper Earth has ever seen. Could it reach the moon? For this experiment, you'd be housing 10,000 people on each floor. And that would make your Iceland building almost half as tall as the Eiffel Tower in Paris. That's not as exciting as some of our next skyscrapers are about to get. And it would only take you just over 2 minutes to get to its top floor, which would be floor 34. Still, it would be good practice for you to figure out the infrastructure to support all your residents. Next on the list, the Australia skyscraper. Now, this is where things get interesting, because at 10 kilometers high, this building would be taller than Mount Everest. And to commute all the way to the top of your Australia skyscraper, you'd need to spend 2 hours and 40 minutes one way. But that's nothing compared to our next engineering feat. To shelter every resident of the United Kingdom, you'd need to think bigger than Big Ben's height. Like almost 300 times bigger. Your United Kingdom skyscraper would have a whopping 6,800 floors. It would reach a height of 27 kilometers, and after floor 4,500, you'd now be above the clouds. The Philippines is home to over 100 million people, and to house all of them, your skyscraper would need to be 40 kilometers high. This man-made monolith would have 10,000 floors, and most of it would be above the clouds. It would take you 11 hours to get to the top floor of the Philippines skyscraper, so hopefully you don't have to come down all that often. Moving on up to something a little taller, your Mexico building would be a jaw-dropping 52 kilometers high. That's twice as tall as the tallest mountain in the solar system, Olympus Mons on Mars. It would take you 14 and a half hours to travel all the way up to its 13,000th floor. Once there, you're halfway to outer space, but at least you'd still have the atmosphere around you. I can't say that about your next megastructure. The United States skyscraper would be really tall, reaching a height of 132 kilometers. And after floor 25,000, you'd officially be in space. Pretty cool, huh? But only if you don't think about the wild temperatures just outside your window. The top of this building would be in the thermosphere, and contrary to what you might think, this layer is incredibly hot, rising to 2,500 degrees Celsius. But if you were to open a window, you'd feel cold. That's because in this layer of our atmosphere, there aren't enough air molecules to transfer that heat to you. Oh, and that would also make breathing impossible. So you'd really need to focus on installing a proper oxygen support system, for the penthouse tenants to survive. Okay, on to one of the most populated countries in the world. The India skyscraper would be unimaginably tall, reaching a height of 552 kilometers. That's 138,000 floors. And to get to the top, you should expect a travel time in excess of 6 days. If I lived way up there, I don't think I'd ever go down. The India skyscraper would be taller than the orbit of satellites and even the International Space Station. Now that you'd be in space, you'd really need to build proper oxygen, water, and waste systems. You'd have to think about how to feed all those people because transporting food from the ground would be virtually impossible. And now, to the tallest skyscraper of all time, the super megastructure that would hold all 8 billion of us, the Earth Tower. The Earth Tower might not reach the moon, but it would be almost as tall as the moon's diameter. This incredible structure would have 800,000 floors, and it would peak at a mind-boggling 3,200 kilometers. Depending on where you'd live here, you'd see planes, satellites, and the ISS. It's somewhat ironic that most of the Earth Tower would be in space, well above our planet's atmosphere. Forget about a balcony with a view of the moon. You wouldn't want to go outside unless you were wearing a spacesuit. Okay, now let's talk about trying to piece the tower together. In addition to its own weight, it would need to support the weight of the entire global population. At about 356 million tons, this would already be nearly 1,000 times heavier than the Empire State Building. To provide everyone with clean water, add to that the equivalent of 4.5 million Olympic-sized swimming pools that would be consumed every day. And I'm not even talking about food or other essential stuff here. The lower floors of this megastructure would be dark and gloomy. There'd likely be high crime rates as people did whatever it takes to survive. The top floors would belong to the rich. They'd be dependent upon the work of these lower levels. Life would be complicated in our giant new skyscraper. Infectious diseases could spread at never-before-seen speeds. Overcrowding would lead to widespread mental health issues. But at least you'd have an incredible amount of room to enjoy outdoors on the ground level, with everyone in one building. Only your elevator commute from the very top floor to the bottom would take you about 37 days. Maybe things could be worse than living way up high in the sky. Like, what if every single person lived underground? Well, that's a story for another What If.